Alright, this is the review for the second test, AP Calculus on derivatives and derivative concepts. For number 1, I'm back to the limit as x approaches 0, the x value 0, from the right. So as I'm coming from the right, I want to know what y value I'm getting closer and closer to. And the y value I'm getting closer and closer to is y value of 1. Now we're going to limit as x approaches 0. This is a double-sided limit. So from both sides, as I get closer and closer to 0, from the left and the right, notice they don't meet at the same place. So that's considered a jump discontinuity. So D and E, the limit does not exist. Now as the limit approaches 5 from both sides. So as I approach 5 from both sides, bingo, the limit does exist, and the y value is 2. As x approaches 7, from both sides. So there's 7. Now the y value at 7, as I get closer and closer, is right there. As x approaches 7, the y value is 1. Number 5. Now these are xy values. These aren't limits. These are just xy values. When the x value is 0, what's the closed circle y value? 3. When the x value is 3, what's the closed circle y value? No, not there. 4. When the x value is 4, what's the y value? There is a closed circle there. A lot of people are making that error. There is a closed circle there. The y value is 2. Now I want to know what the derivative at negative 2 is. Derivative is asking you what's the slope of the curve at negative 2. The slope of the curve at negative 2, that's a cusp. So there is no slope there. That's a D and E. I want to get that out of the way really quick, that idea. What's the slope at x value 1? So a lot of people think, well, there's no slope here. There's no slope here. There is a slope there. Its tangent line is 0. So the slope is 0 there. What's the slope at x value 7? Another tricky one. This goes from concave down to concave up. Okay? And the slope of this line is negative. The slope of this line is negative. But as I get closer and closer, there's actually a vertical slope for a precise second. So because it's a point of inflection and the slope of the line is undefined, we're going to say D and E again. Continuity. Where on this curve, from negative 4 to positive 8, are there discontinuities? And how many times are there? The continuity I'm picking up my pencil is discontinuous. So I don't pick up my pencil here. Here I have to pick up my pencil. So that's 1 discontinuity. Don't have to pick up my pencil. I have to pick up my pencil. That's 2 discontinuities. Now I want to know where it's differentiable. Not differentiable. Okay? Not differentiable. That means that either a jump, a cusp, or a vertical asymptote. So let's see. Vertical tangent line. So that's 1 place, it's not differentiable. That's 2. That's 3. That's 4, that's a cusp. That's 5, that's a cusp. This here vertical, 6. So there's 6 places where it's not differentiable. Back to evaluating limits. I plug in the 1, I get 0 on the bottom. I plug in the 1, 1 cubed is 1. I get 1 minus 1, so that's going to give me 0 on the top. Now I'm going to implement L'Hopital's rule. And I'm going to take the derivative of the top and the derivative of the bottom, and then plug the 1 back in. So the derivative of the top is 3x squared, derivative of the bottom is 1. I plug this 1 in there, and that gives me 1 times 3, so this limit is just 3. Number 14, I plug the 1 in. 1 minus 1 is 0 on the bottom. 2 minus 1 is 1 on the top. That limit is D and E. Not that difficult. There's a long version of this, and there's a short version to it. I prefer the short version. I just take that, and it's negative 1 over 25. I explained that technically you're taking the derivative of 1 over x, and then plugging in 5 at the very end. This one, when you plug in 0, you get 0 over 0. Then you implement L'Hopital's rule, and you get 21 over 3. And 21 divided by 3 is just plain old 7. For number 17, I'm going to do it. I'm going to put my answer down here. So it's going to be a big division bar with a minus sign. In the back, it's going to be 3x squared plus 2x, minus 2x. I'm getting ahead of myself. Plus 5, close parentheses, all over h. Up front, it's going to be 3 parentheses, x plus h squared, minus 2 parentheses, x plus h, plus 5. I'm going to squeeze that 5 in. Now I'm going to do the petty algebra. This is going to give me 3 times x squared plus 2hx plus h squared, minus 2x, minus 2h, plus 5, minus 3x squared, plus 2x, minus 5, all over h. Distribute the 3x squared, that gives me 3x squared plus 6hx plus 3h squared minus 2x minus 2h, almost wrote x again, plus 5 minus 3x squared plus 2x minus 5 all over h. And from experience, you'll start to notice it cancels out from the back end. So the negative 5 and the positive 5, the positive 2x, the negative 2x, the negative 3x squared and the positive 3x squared. This is going to leave me with just plain old 6hx plus 3h squared minus 2h all over h. I pretzel it, that gives me 6x plus 3h minus 2. Please don't forget to jot your answers down over here so I can grade them rapidly. Finding derivatives. This one's pretty straightforward. I'm going to bring this up and write it as x to the negative 1 so I can use the general power rule. So y prime is going to equal 6x squared plus 3. Negative 1 times negative 4 is positive 4x to the negative 2. And I'm going to rewrite my answer over in the answer spot, and I'm going to simplify that as I do it. So that's going to give me 6x squared plus 3 plus 4 over x squared. I'm going to rewrite 19 as a rational exponent. So this is not y prime notation. This is just x to the 2/3. What's in the bucket goes on the bottom. Implement the general power rule. That's going to give me y prime equals 2/3 x minus 1. So that's going to give me negative 1/3. So that's going to be rewritten as 2 over 3 x to the 1/3. Now I'm going to rewrite that in radical form. So it's going to be 2 over 3 cube root x. I'm going to write that answer down. 2 over 3 cube root x. And I cannot simplify that one any further. This one's a little harrowing. I'm going to rewrite that so I can implement general power rule. That derivative is pretty straightforward, but I'm going to bring this up as x to the negative 2. I'm going to rewrite square root of x to the 1/2. So this is going to give me x squared minus x to the 1/2 times x to the negative 2. And now I'm going to do 1/2 minus 4 over 2, that's negative 3 over 2. So it's going to give me x squared minus x to the negative 3 over 2. And now I'm going to implement general power rule. Alright? 2x, positive 3 halves, x, subtract 1, 2 over 2, that's negative 5 halves. I'm going to rewrite this up here, that's 2x, plus 3 over 2, square root, x to the 5th. Now that can be simplified, but I'm not going to do it on this test. We're going to simplify that later on a different test. Product rule, I have a u equals x, a v equals cosine x, a du equals 1, a dv equals negative sine x. So I'm going to do my u dv. So it's going to be negative x sine x plus v du cosine x. Another product rule. Number 22 is a product rule. So I have a u value of root x, and I have a v value of sine x. And the derivative of u, this one's a fun one, it's just 1 over 2 root u, 2 root x, I'm sorry. And the derivative of v is just going to be cosine x. So I'm going to do u dv, so it's going to be square root x times cosine x plus v du. Now, we're going to plot that sign on top of the 2 root x. And that's it. Pretty smooth. For number 23, a quotient rule. So the high is going to equal sine x, and the low is going to equal x minus 2. The derivative of the high is going to equal cosine x, and the derivative of the low is going to equal 1. And then I'm going to do low d high. I like to put the polynomial first. Less high d low, and square below. Draw the line and square below. So I'm going to square that. That's it. Pretty smooth. Number 24, another quotient rule. So I have a high value of x squared minus x. I have a low value of cosine x. The derivative of the high is just going to be 2x minus 1. The d low, the derivative of the low, is going to be negative sine x. So here I go. I'm going to do low d high. Again, I usually put the polynomial first. So that's low d high cosine x less high d low. Notice there's a minus sign here. So that's going to give me x squared minus x times negative sine x. This is going to change into positive. Sine x, low d high less high d low, draw the line, and square below. So the bottom is going to be cosine squared x. This one, if you think you're going to do quotient rule, good luck. But you should know a couple of trig identities. That 1 minus cosine squared x is a version of this Pythagorean identity. Sine squared x plus cosine squared x equals 1. So when I subtract cosine from both sides, that leaves me with sine squared on the top. So this is going to equal, this is not a derivative, this is sine squared x over sine x. And then one of these cancels out, and that leaves me with just sine x. Now when I take the derivative of sine x, it's just cosine x. Number 26, I want to find the equation of the tangent line. I need to find the y value to do that, so I just plug that y value in. 3 times 1 squared is 3. 3 minus 2 times 1, so 3 minus 2, that's going to give me a 1 for the y value. Now to find the slope, I take the derivative. So I want to actually find the derivative at x equals 1. So this is going to equal 6x minus 2 at x equals 1. 6 minus 2, the slope is 4. So now that I have the slope and the point, I'm going to use the point slope form. So I have a point of 1, 1, and a slope of 4. So y minus y sub 1 equals 4 times x minus 1. Distribute the 4. That's going to give me 4x minus 4, and then add 1. So it's going to give me 4x minus 3. Same process. I want to find the y value, so I plug the 5 in. 5 plus 3, that's 8. 5 minus 3, that's 2. So this y value is going to be 4. Now I take the derivative of this. I'm actually going to use the Casio to take the derivative of this. Pretty helpful. I can do it by hand, but I'd like to just see what happens. So I'm going to hit shift, dy dx. Got to be in mode 1. Shift, dy dx. Pretty nice. I'm going to hit my fraction bar. Now I'm going to type in x plus 3. To type in x, you have to hit the alpha button. Okay? So I'm going to hit alpha x, which is the parenthesis. Alpha x plus 3 over alpha x minus 3. And I just hit enter. Oh, I have the right arrow over to x equals 5. And there it is, negative 1.5. If you want the fraction value, just type in negative 1.5 and it'll work it out for you. Negative 3 halves. So the slope is negative 3 halves. I could have done it by hand, but it's a convenience. Negative 3 halves. So now I want to find the equation of the line. So I have the point at 5, 4. And the slope equals negative 3 halves. Y minus 4 equals negative 3 halves times x minus 5. Distribute the negative 3 halves. So that's going to give me negative 3 halves x plus 15 over 2, which I think is 7.5. And then I add 4. And that's going to give me negative 3 halves x plus 11.5. I want to find the y value when x equals pi. So sine of pi is going to be the y value on the unit circle over here. So this is negative 1, 0, and the sine of pi is going to be 0. So this coordinate is going to be pi, 0. Now I want to find the slope, so I take the derivative, so that's going to be cosine at pi. The cosine value at pi is negative 1. So the slope is negative 1. Y minus 0 equals negative 1 times x minus pi. Distribute the negative, and that's going to give me negative x plus pi. This one I don't want to do any calculus on. This is algebra 1, that's a line. The y-intercept at x equals 0, I just plug in the 0, is going to give me 0, 2. The slope everywhere on this line is 3, and the equation of the line anywhere on the line is that equation, 3x plus 2. This is the limit definition of continuity, so I have to find a letter where these are equal at x equals 1. So I have x to the 5th equals ax plus 2, at where something weird or wonderful happens at x value of 1. So I plug the 1 in for the x value, that's 1 to the 5th is 1. 1 times a is a plus 2. And then I subtract 2 from both sides, and that gives me a equals negative 1. This particular problem, again, I set them equal to one another. Something weird or wonderful happens at x value of 1. So that's going to give me a e to the x minus 1 plus 3 equals the inverse tan of x minus 1 plus 2 at some value of x where x equals 1. So I'm going to plug in this value of 1 everywhere there's an x. So 1 minus 1 is 0. E to the 0 is 1. So this is just going to give me a plus 3 equals the inverse tan. So at what value, when I plug in 1, what value is tangent when that's 0? So the inverse tan, take a look. The inverse tan of 0 is 0 radians. So that's going to give me 0 plus 2. Solve it for a. I subtract 3 from both sides. Again, I get a equals negative 1. Last page, rate of change. What I want to do here is find the average rate of change. So I'm going to do the f of b minus f of a, the interval from a to b, all over b minus a. So I like to do the 4 minus 0 on the bottom. And then on the top, I put the function. So I have the function on this side and the function on this side. And this is going to be something squared plus 6. And this side is going to be something squared plus 6. And I just throw in that 0. I just throw in that 4. And that's going to give me 16 plus 6, 22. Keep a little tally, I guess. Minus 6. That brings me back down to 16. All over 4 minus 0 is 4. So the average rate of change is going to be 4. The instantaneous rate of change at 0 and the instantaneous rate of change at 4. I'm going to find the derivative of x squared plus 6. And that's going to give me 2x. I'll leave that blank so I can pop my 0 in. And it's the same for both of them, so I'm just going to throw in 0, and that's going to give me an instantaneous rate of change is 0, and over here the instantaneous rate of change is going to be 8. This one, I advise you not to do this one on the calculator because it will give you an error. So I'm going to set up my template, and it's again going to be 4 minus 0, and then it's going to be something root x, something root x, minus something root x. Whoops, and I just put the 0 in and the 4 in, so this is going to be 4 and 4, this is going to be 0, and I'm sorry, that's 0 also. The square root of 4 is 2, 2 times 4 is 8, this all adds up to equal 0, so it just gives me 8 over 4. So my average rate of change between those 2 points on that interval is 2. The instantaneous rate of change, the derivative at 0 and the derivative at 4, we're going to do by finding the derivative of that. So I'm going to rewrite this as x to the first times x to the 1/2. That gives me x to the 1.5 or 3 halves. Do the general power rule, so that's going to give me 3 halves x. Subtract 1 from that, and that's going to give me x to the 1/2, or 3 square root something over 2. 3 square root something over 2, and I'm going to throw in the 0. This is going to give me 0. I'm going to throw in 4. That gives me 3. For this one, both the AROC, the IROC, for f of 0 and f of 4 is going to be the same. It's going to be 5, 5, and 5. Because this is a line with a y-intercept of negative 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. It goes up 1, 2, 3, 4, 5 over 1. 1, 2, 3, 4, 5 over 1. The slope never changes. So the average rate of change between any 2 points is going to be 5. The instantaneous rate of change at any point is going to be 5. And that's it.